Welcome to today's deep dive. I'm your host, and today we're asking you to imagine sitting in a massive stadium.
Oh, yeah. Hi, everyone. Glad to be here to dig into this.
So 80,000 screaming fans, a big play happens on the field, and a split second later, hundreds of giant screens all around the concourse replay it in perfect, flawless sync.
Right. No lag, no buffering. Just
Yeah.
instant reality.
Exactly. And that invisible magic, it doesn't happen by accident. Today, we're looking at the exact hardware making it possible. It's a highly specialized device from an HDTV Supply catalog called the ZeeVee Z4KF2XS-D ZyPer4K-XSE fiber decoder.
That is a total mouthful.
It really is. So, okay, let's unpack this. It's essentially an HDMI 2.0 decoder streaming over a 10 gigabit fiber optic network. But why should you, our listener, actually care about a $1,460 AV box?
Well, because without it, modern digital infrastructure kind of just falls apart.
Wait, really?
Yeah. What we're really talking about here is moving massive amounts of data at the speed of light. So this box delivers uncompressed 4K video at 60 frames per second.
Uncompressed, so no quality drop at all.
Right, none. And the catalog highlights a really specific spec here. It's 4.4.4 resolution.
Okay, and that means what exactly?
It means it isn't compressing the color data to save space. You know how your home streaming services kind of do that?
Oh, right, where the dark scenes get all blocky and weird.
Exactly. But here, every single pixel on the screen gets its full original color information.
Wow. And because it's using fiber optics, which is, literally shooting light through strands of glass.
Yes, tiny glass strands.
Right, so it completely bypasses the processing delays you get with traditional copper wires or, your standard home Wi-Fi.
Which is huge.
Yeah, and that is how it achieves its biggest selling point, which is zero frame latency. I like to think of it like looking through a physical glass window. You aren't watching a processed digital reconstruction.
You're seeing it instantly.
Because you are quite literally watching light travel through glass.
Yeah, and what's fascinating here is why that strict zero frame latency is actually mandatory.
Mandatory? Like you can't just have a tiny half-second delay.
Not in these settings. Think about that stadium we talked about, or a massive sports bar on Super Bowl Sunday. You have dozens of screens showing the exact same live feed.
Right?
If there was even a fraction of a second delay between screens, you get people reacting out of sync.
Oh, I've heard that happen. One side of the bar cheers before the other side even sees the play.
Exactly. It creates this disorienting echo effect that completely ruins the live experience.
So transmitting data via light solves the speed problem. But keeping that light sharply focused over long distances without the signal degrading, that has to be the real engineering challenge, right?
It is. And this is where the hardware specs really separate this device from standard commercial gear.
Yeah.
It operates on two types of fiber.
Okay.
It can go 300 meters on multimode fiber, which uses a thicker core to bounce multiple light beams for shorter distances. But it can also use single-mode fiber. That's a microscopic glass core that shoots a single, highly focused laser.
A laser, wow.
Yeah, and using that, the signal can travel 10 kilometers.
Wait, 10 kilometers?
Yeah, that's over 6 miles.
Over 6 miles for a single TV signal. Okay, who on earth needs to send a TV signal 10 kilometers away? Here's where it gets really interesting to me. You see specs like that, along with support for massive 15 by 15 video walls.
Yep, and a multi-view setup handling up to 19 different sources.
Right, so you realize this clearly isn't just for a really nice living room setup.
No, definitely not. If we connect this to the bigger picture, you have to think at an enterprise scale. Sprawling university campuses, military bases.
Big government complexes, maybe?
Exactly. You might have a central control room that needs to feed dozens of high-definition displays located miles away in completely different buildings, all without a single dropped frame.
But when you are beaming sensitive, uncompressed data across a massive 10-kilometer campus, securing that signal becomes pretty critical, right? Anyone tapping into that fiber could just intercept the feed.
Yep, and that explains the heavy security specs in the catalog. It features AES 128 encryption and HDCP 2.3 for content protection. It also explains the TAA compliance.
TA, that's the Trade Agreements Act, right?
Right. It requires products to be manufactured in the U.S. or approved countries. If a device isn't TAA compliant, federal government facilities legally cannot buy it.
Oh, wow. I didn't know that.
So that certification is totally mandatory for this level of secure infrastructure.
Yet for all these dense military-grade specs lasers, single-mode glass, federal compliance, the most surprising thing in the source material was entirely human.
Oh, the review.
Yes, there's a customer review specifically praising an HDTV Supply rep named Rachel. Apparently, she caught a mistake the customer made during the ordering process, fixed it manually, and basically saved the project.
It's a great reminder, honestly, you can have the most advanced encrypted 10 gigabit fiber network in the world. But human oversight, someone actually paying attention on the other end of the line, is still a massive competitive advantage.
Absolutely. So what does this all mean for you? Next time you're walking through a sprawling airport or a massive arena and you see dozens of flawless 4K displays acting as one perfectly synced image, you'll know there's likely a network of specialized fiber decoders working invisibly behind the scenes to make it happen.
Which raises an important question to leave you with today.
Oh, let's hear it.
If we can currently transmit flawless, uncompressed 4K video instantly across 10 kilometers of glass fiber for commercial use, well, how might this invisible zero-latency infrastructure eventually revolutionize your everyday personal remote communications?
That is definitely something to think about. Thanks for diving in with us, and we'll catch you next time.